Welcome back to Office Hours with Dr. Clark. Today we are going to be looking at redox reactions. Let me get my whiteboard here, ready to go. Okay, redox. Redox reactions. So redox involve transfer of electrons. In a previous video, we talked about metathesis reactions. Those do not involve transfer of electrons. Those are the swapping partners. So redox reactions, there's oxidation, that's loss of electrons, or increase in oxidation number. And I'll explain oxidation number in a second. It's kind of a abstract concept. Reduction, gain of electrons, or decrease in oxidation number. So oxidation number is a way for us to kind of track how willing element is to become oxidized or reduced, right? So the lower your oxidation number, the more easily oxidized you are. The higher oxidation number, the less easily oxidized you are. Or the opposite is true. So if you have a high oxidation number, you're more easily reduced than if you have a lower oxidation number. So it's a way to kind of track how easily something's going to lose electrons, for example, like a metal. So we can rank metals in terms of how great they are at being oxidized or great they are as reducing agents. So let's talk about the agents. An oxidizing agents or an oxidizer, you see some like bleach is an oxidizer or an oxidizing agent. Oxidizing agent gains electrons or decreases in oxidation. I'm going to call oxidation number ON for short. That's to kind of save time. Um, that's the same as oxidation number. A reducing agent, a lot of metals are reducing agents. Reducing agents, they lose electrons, increase in oxidation number. So your whatever is reduced is your oxidizing agent, and whatever is oxidized is your reducing agent. Okay. So bleach is an example of oxidizing agents. Uh, Copper is an example for reducing agents. Okay, so let's look at some reactions. So let's look at magnesium plus oxygen to get magnesium oxide. Let's give some states. So this is a brilliant, like very hot white burning flame when magnesium burns in oxygen. It's very pretty. Let's do some balancing here. So let's look at it from the perspective of electrons. So magnesium charge is 0 and it's 2 plus here. Oxygen is 0 here and it's 2 minus. So magnesium goes from 0 to Mg 2 plus. So it loses 2 electrons. Oxygen goes from 0 to 2 minus, so it gains. So magnesium is oxidized, oxygen is reduced. Let's look at it from the perspective of oxidation number. So all elements, the oxidation number is zero. So they're kind of neutral. They can either be oxidized or reduced, right? That's really what zero says. Now, a monoatomic ion, the oxidation number is the same as the charge. So magnesium has an oxidation number of 2, oxidation number of -2. So we have an increase in oxidation number, that's oxidation. We have a decrease, that's reduction. And we can tell the agents, oxygen is the oxidizing agent, because that it gains electrons and it's being reduced. Magnesium is reducing agent. Okay. So now let's look at a reaction where we're not clear that there's some transfer of electrons going on. Let's look at CH4 plus O2 gives you SO2 plus, I'm sorry, CO2 plus H2O. Let's balance this quickly. These are all gases. This is CH4 is natural gas, which we use a lot for heat and for cooking. So there are rules for oxidation numbers. So one rule is oxygen in most compounds, oxidation number is -2. Hydrogen in most compounds is +1. There's some exceptions. If it's a metal hydride, meaning like, NaH, the hydrogen is gonna be -1 here, right? In peroxides, oxygen is also -1, like say H2O2. Oxygen says -1. So there's some exceptions. Now, carbon can be all over the place, so we can actually solve for the oxidation number. So in a neutral compound, the sum of the oxidation number will always be 0. So we can just do some algebra. C plus 4 times +1 equals 0. So C is -4. In carbon dioxide, C plus 2 times -2 is equal to 0. C is equal to +4. So carbon goes from -4 to +4, so that's oxidized. Right, so methane is, CH4 is oxidized. So CH4 oxidized. So the carbon is an active component here. The hydrogen, nothing happens to it. It's still +1. It's +1 in water. And an oxygen goes from 0 to -2 in both cases. So O, 0, O, -2. So we have reduction. So this is a molecular type reaction. So there are no ions involved, so we can't look at charges. So we have to remember our oxidation rules. Right. So now what if we have something like sodium sulfate, and we're trying to figure out the oxidation number of each component? So oxygen is -2. We know that sodium being an ion is going to be +1. Sulfur, we don't know what that is. Actually, you know what? Let's just look at sulfate, because I want to give an example of what you do with polyatomics. So the sum of the oxidation number must equal to the charge. So S plus 4 times -2 is equal to -2. So S is equal to +6. So that's the oxidation number of sulfur in sulfate. That's how you find those. So now metals are very interesting. They compete in a sense to see who is a stronger reducing agent. It's almost like if you watch basketball, think of March Madness, who's gonna defeat who in the playoffs, who's ranked number one, number two, etc. So we can rank metals according to how strong they are as reducing agents. So zinc plus copper sulfate will react to form copper metal plus zinc sulfate. However, the reverse will not happen. Copper will not replace zinc in any compound. So the implication there is that zinc is a stronger reducing agent. So now let's pick apart the compounds, the reaction to see if zinc indeed is the reducing agent. So it goes from 0 to 2 plus, copper 2 plus to 0. So 0 to 2 plus, zinc is oxidized, therefore it is a reducing agent. Copper is reduced, copper 2 plus, therefore it is the oxidizing agent. So reducing agents, oxidizing agents. So we call these reactions single replacement reactions. Single replacement reactions. And hydrogen actually can act like a metal here. So magnesium can displace hydrogen from acids. So you get the bubbles forming, which everybody loves to see in chemistry lab. Students all get so excited when they see magnesium and hydrogen reacting because it's a pretty vigorous reaction. Balance it here. So magnesium 0, 2 plus, hydrogen plus 1, 0. So magnesium is Mg is oxidized. It goes from 0 to plus 2. H reduced. H plus goes from plus 1 to 0. Magnesium is the reducing agent. HCl is the oxidizing agent. Magnesium is more active. That's another way to say it. An activity series, meaning how strong is your reducing power as a metal. Now, interestingly, copper will not replace HCl, displace hydrogen, no reaction. But hydrogen will replace copper. So this actually can be a thing. With hydrogen, copper, and copper compounds. So H2 is actually more active than copper. So we can say for sure magnesium is more active than H2, which is more active than copper. And we can put zinc in there. So we could call magnesium the 1 seed and H the 2 seed, copper the 3 seed, if we're thinking about, sports. And we find that magnesium will actually replace zinc. maybe the mover phase thing. So we can change this now to magnesium. It's more active than zinc, which is more active than hydrogen, which is more active than copper. So magnesium is the one seed, copper is the four seed. Okay. Okay. So just wanted to, go over some redox reactions, and they can get redox reactions can get way more complicated than this. And there's actually a whole lesson about balancing redox equations, more complex redox equations that's, outside the scope of Gen Chem 1. But until next time, Alpha Star is about to collect.